Okay, so starting for tonight's homework, you actually are going to be doing more exponent rules, right? And let's just first review what you know, and then we'll review this new piece of information. So the first rule you learned was that if you had the same bases, two numbers with the same bases, meaning x would be the base, and that's 10, x to the 10th. 10th is the exponent or the power. Make sure you can see this. Times same base raised to the 8th power. We know that it's going to be x, the same base, to the, all you have to do is you add the exponents. When you multiply same bases with exponents, you add the exponents. You keep the base, right? So the rule actually is this. X to the m times x to the n is equal to x to the m plus n. Exactly. So that's the rule. I'm going to erase this. That was the first rule. Now there is another rule. I would have taught something differently, but they're going. I'm going in the order that they're going in. There's a lot of stuff on this one. Sorry?
It's our costumes from moving.
Oh, I see. Okay. So tonight's homework involves what do you do when you have a negative exponent? Okay? A negative exponent where you have x to the negative number. I'm going to put just an n for now, because that n could be anything, right? X to the negative 3, x to the negative 10, x to the negative 5. All right? So this is the formula. X to the negative n is equal to 1 over x to the positive n. All right? So when you have a negative exponent, I actually mentioned this, maybe 2 weeks ago to you guys when we were talking about exponent rules. Remember that?
Yeah.
That when you have a negative exponent, most people think that a negative exponent means it's going to be a negative answer. It is not going to be a negative answer. When you have a negative exponent, all it means is you have a fraction. You have a number less than 1 but bigger than 0. Unless, of course, unless I had a negative sign here, then you would have a negative answer. But given just this, then no, it would be a positive answer. So examples would be, so here's some examples. We've got x to the negative 3 is equal to 1 over x to the positive 3. Right?
Oh, I get it.
X to the negative 10 is equal to 1 over x to the positive 10. Now, there is something about this that's actually worth talking about a little bit further. I'm going to just take this one, x to the negative 3. I'm going to do it over here. X to the negative 3 is equal to 1 over x to the positive 3. If I wanted to write x to the negative 3 as a fraction, what could I do? Indu. Okay, let's say you don't know what x is. How can you write something as a fraction if it's not a fraction? Sal?
Like, the division problem.
Okay, but what can I do to make some Liam?
Put the number over 1.
Put the number over 1? Does that create a fraction?
Yeah.
That is the same thing? Is that really right? Yeah, that's right. You can always make a fraction just by putting it over 1, right? If it's not in a fraction, technically you're dealing with a numerator. If there's no fraction, there actually is a hidden fraction, and that hidden number is that number is a numerator, right? So look at this. This is called the fraction line or the division line, right? You guys agree with me? What's so interesting about this is that just by bringing the x to the negative 3 from upstairs to downstairs, crossing the fraction line, right? Just by having it cross the fraction line, look what happens. it changes, the exponent turns to the other sign, right? It was negative here, x to the negative 3. Bring it across the fraction line, it becomes x to the positive 3. That means that I could actually bring the x to the negative 3 upstairs, and it would be x to the negative 3 again, right? I could go back and forth. It would be really, really fun, right? Right? I could do that all day. I could do that all night. That would be, you'd never get done with your homework. You could do math forever, right? Yes, Sal.
There's a question about exponents in general. Can you have like 0 as an exponent?
Yes, you can. We're going to actually talk about that in just a second. That's the other thing that we're going to talk about today. So this is really interesting. So let's just sort of see what this means. Watch this. You're going to see the power of this. Let's say I had x to the negative 6 all over y to the negative 3. First of all, are they same bases? I have an x base and a y base, totally different. I have no idea what they represent or what they are. Those numbers are. They're just unknowns, right? I do know that they have negative exponents. I don't want negative exponents. So where could I put this so that it would no longer have a negative 6? Micah, where would you put this? Okay, so where would the x to the negative 6 go to make it x to the positive 6? Right, so all I have to do is bring that downstairs across this division line, right? And that becomes x to the positive 6. And what about the y to the negative 3? All I have to do is bring it upstairs, right? And then it becomes y to the positive 3. So if I just do this, right, y to the positive 3 over x to the positive 6, I have just solved my problem. I've simplified that problem. You see how I did that?
It's really simple.
It's very simple, right? So then let's try a harder one. Let's try, can I erase that? Or you guys don't? I'm running out of space here. All right, so let's try this one. Let's say we have a to the negative 2, b times b to the negative 6 times c squared all over d to the negative 10, e to the 4th, f to the negative 3. That looks a little scary, doesn't it?
And you just like do that, like the adding and subtracting is like the exponents, right?
Well, but wait a minute, what's the rule? The rule is they have to be same bases in order to add exponents, right? There are no same bases. We've got A, B, and C, D, E, and F, right? No same bases. So what I've got to do is I've got to take, and I don't want to have negative exponents. I want to move the negative exponents. Look, those two things could go downstairs. Now that's not a negative, so I'm going to leave that upstairs. This is going to go upstairs. And look, this is going to go upstairs. So now I'm going to just rewrite it. I'm going to do my c squared first upstairs. And then I brought this d to the minus 10. Now that's d to the positive 10. And now I'm going to have f. It's negative 3 downstairs. Bring it upstairs. F to the positive 3 over. Now I'm going to write this first. I just like them in alphabetical order, sort of, you know. I'm going to bring these downstairs to make them both positive. So I've got a squared times b 6, and then I still have this e to the 4th here, right? So I have to include that.
Oh, so you like separate them all to like...
Yeah, so you just have to, anything with a negative exponent, you bring it across the fraction line, and immediately becomes positive. They're so simple once you understand that.
Oh, but you keep the positive.
And the ones that are already positive, they just stay where they are, right? There's no need to, if you move those, then they would become negative. Then you'd have to move them up again, right? So that's, you don't want to spend all night doing your homework. You want, ideally, you want to just, so that is the correct simplification right there. Does that make sense?
Yeah.
I know that's a little, it looks hard, but it's really not. Now let's try another one. Oh wait, I'm running out of time. So that's the beginning. Okay, well, let me talk about one other thing. What time do I have? Okay. All right. So one other example would be something like this. What is 2x to the negative 7? I'm going to put that over 1. I find it really helpful to put anything over 1 when I'm dealing with negative exponents. What does the negative 7 exponent affect into?
X.
It doesn't affect the 2? Does it affect the 2? Yes or no?
Pretty sure it just affects the X.
Yes, exactly. It only affects the x because the exponent only affects what it's next to. And the only way it would affect the 2 is if I had it in parentheses. But there aren't any parentheses. If there was, then it would be different. But with no parentheses, this is the only thing that I move downstairs. The 2 stays upstairs, right? So I keep my 2 upstairs, and I just put my x to the 7th downstairs, and I'm done.
Oh.
Isn't that cool? Let's try another one. What if I had?
What if you had like 5? Just never mind.
So what if I did this? What if I did 5x to the negative 3? Again, I'm going to put it over 1. And the negative 3 now is affecting everything, right? So I've got to bring everything downstairs. So I'm going to have a 1 upstairs left over, right? And then I'm going to bring 5x in parentheses to the positive 3 downstairs. Right? Is that making sense? You guys together? All right, so there's one last rule I have to tell you about. All right, can I erase this? I'll erase up here. There's one last rule. Nate, do not ring the bell. Nate.
He's going to.
Dina, don't let Nate ring the bell quite yet. Wherever he is, don't let him ring the bell. All right. Here we go. This is a great video, right? Okay, so here we go. This is the last rule that we're going to learn today. X to the 0 power. Sal was asking about this. Equals 1.
What? Oh, yeah.
Anything to the 0 power. So I'm going to write it this way now. Anything to the 0 power. I got to put it in parentheses because otherwise the 0 power would only affect the g, right? In anything, right? Yeah. So I got to put anything in parentheses. Anything raised to the 0 power is equal to 1, right?
Wait, why?
So I could give you this like horrible, awful problem. I could say negative b plus or minus the square root of b squared minus 4ac all over 2a raised to the 0 power.
Oh, that equals 1.
Equals 1.
Oh,
okay.
That is so brilliant.
So you just got to remember, though, that the 0 only affects what it's next to. That's a negative b. This actually is part of the quadratic formula. What?
What's up with the plus minus sign?
Oh, it's an equal sign.
Oh, this?
Yeah.
Oh, that is actually a plus or minus sign.
What's that mean?
And you will learn that actually this year at some point.
It's either plus or
I will show it to you, but it's probably one of the last things you'll learn this year. So.
Wait, why does it equal 1?
Okay, one last example.
Yeah, you'll get to choose.
Okay. What is all right.
It equals like 1.
So first thing I'm going to do is I notice 5/10. 5 goes into 5 once.
Twice.
5 goes into 10 twice.
There we go. It's just like 1.
All right, so I have now got 1x squared. What is y to the 0?
1.
That equals 1. Do I have to put a 1 here?
No.
Because 1 times this is this, right? So that's what I've got. I've got 1x squared over 2. Or I don't really need this 1 either. So I could say that equals x squared over 2. Does that make sense?
Yep.
When you see something raised to the 0, it didn't raise the whole thing to the 0. it raised just the y to the 0, that means the y just becomes a 1. I mean, y to the 0 is equal to 1. Right? Now, had I done it this way, had I done 5x squared...
Here, you have like
Okay.
less than 20 seconds.
Nate, you may ring. You have my permission.
Never mind, fine.
All right, guys, that's it for today.